Let's move on to our subject for today, which are vectors. Okay, here we had a couple of people who can put us on the right track, and they started criticizing or giving their ideas about what a number is. Remember, we covered number and then number line, and the vectors, we're going to say, are very much related to those, okay, especially the mathematical vectors, not so the physical vectors. Okay, so one fellow says the following. He says, a number isn't the count, which is what we said here, okay? A number is the symbol or word. Absolutely not. That's called the numeral, okay? Number is not a numeral. The numeral, there you see the definition. That's not my definition, by the way. That comes from the establishment, okay? A figure, symbol, or group of figures, number line, or symbols denoting a number. Okay, so the numeral is the hieroglyphic that you put, the little drawing that you put in on paper or wherever. Okay, that symbol is known as the numeral. What does it represent? It represents a number. What is number? The verb to count. It's a verb. Okay, as you can see it down there at the bottom. Okay, counting. Okay, 5 is the numeral. Okay, numeral 5 represents number. The problem here is that sometimes we say the number 5. We should be using the word numeral and say the numeral 5, okay? But we're referring to the quantity, meaning what does the 5 represent, and we call that a number, but we say the number 5, and that's where people get confused. Now, we should say the numeral 5, which represents counting. You counted 5 times. You know, you moved your arm back and forth and said 1, 2, 3, 4, 5, okay? That's what it stands for, because we have another gentleman here who brought up an issue, okay? Anyways, the numeral 5 is the waving of the hand up and down. That's what it is. How many times? I don't know, depending on what numeral you're talking about. Okay, so that's the difference between a numeral and a number, okay? Let's see if we can get that straight. Here we have another gentleman. He says the following. He says, to count is an action. Yes, absolutely right. If you don't count, then you haven't counted. No, absolutely wrong. I say Joey could have run. Did you understand what I just said? Well, do you understand the meaning when I say run? Does Joey have to run? Do I have to run? No, I just need to understand the word run. Okay, not everybody in the world has to run in order to talk about the word run. Certainly a person who's quadriplegic might not be able to run, okay? So, but hopefully they can understand the word run, what the word run means. We are distinguishing between operations and counting. No, absolutely not. That's not what we're doing. We are defining the word number, okay? Let's see if you can concentrate on that. We are distinguishing between actual counting and the meaning of the verb to count. Okay, so you don't have to actually count, you just have to understand the meaning of the verb to count. What does to count mean? Doesn't mean you're going to count just to say, oh, I want to understand the word to count, so I'm going to count. No, you don't have to count. You just have to understand the word to count. 1 billion can be said and a hand waved. Yeah. Is that what 1 billion is conceptually? Yes, that's what it is conceptually. That's what you did. 1 billion is to count until you say 1 billion. No, absolutely not. You don't have to count. We don't all have to count to 1 billion to understand what the term 1 billion or the symbol 1 followed by 9 zeros means. Okay, 1 billion means that the numeral 1 followed by 9 zeros stands for hand waving to a billion. Okay, in fact, there was one fellow, someone mentioned it, so I looked it up, and he's right. It says Jeremy Harper is an American entrant in the Guinness Book of World Records for counting aloud to 1 million, live streaming the entire process, which took what? 89 days. So the guy went to sleep, woke up and kept counting, okay? It took 89 days, and he began on June 18, blah, 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 okay, and ended up in September, right? His million count website and forum were taken down some months later. During the count, he neither left his home, etc., etc., etc. Okay, so someone apparently did count to 1 million. It took him 89 days. I doubt anybody has ever counted to 1 billion. Okay, so does that mean we don't know what 1 billion is because nobody has ever counted to 1 billion? No, we say that a 1 followed by 9 zeros represents the moving of your finger 1 billion times. That's what it represents. You have to understand the numeral, the symbol that represents counting. Okay? And again, you can't count to half. You can't count to 3/4. You can only count integers. 1, 2, 3, 4, 5, 6, and so on. Okay? You can only count integers. You can't count to 0. Okay? You can't count 0 apples, because 0 apples is the same as 0 trees, 0 elephants. Okay? So we don't count to 0. So 0 is not a number according to that definition. And again, you have all these negative numbers. Those are not numbers, okay, because those are operations performed on numerals, which represent numbers, which are counting. Okay, we got that? Okay, so here we have another fellow. He says the following. I'm not sure if it's the same one. It says, time is a 4-dimensional locational variable. The hypercube is geometrical 4th dimension. XYZ plus time is XYZT. Well, we had a problem because I said the other day that time is a number line. And this fellow says it's a dimension. And today we're going to argue that time is actually a vector. But for this, we need to define these and what do these words mean? And again, we have to look at the definitions of math and the definitions of physics. Okay? So under the definition of physics, not even a vector or a dimension, it's a number line. But if we're going to go with the definition of mathematics, then time is a vector, not a dimension. Okay, so that's the argument. And here you can see you have X, Y, Z. Let's call it length, width, and height. Those are the 3 dimensions, right? The names of the dimensions, unless you have some other name, then those are standard. Okay, those are dimensions at least of physics. What they are in math, I don't know. What they call these 3 dimensions, I don't know. We call them length, width, and height in physics. But time is not a dimension, and you can see why from his example. He's saying, look, this is the hypercube, and that's a 4-dimensional object, and it's a XYZ plus T, T meaning time, right? There you see time in green. What are we talking about? We're saying that this cube expands and becomes a bigger cube. That's what the static image represents. In other words, the green lines that go from corner to corner, from the small cube to the big cube, that's an illustration that's depicting an expansion of the cube in three directions. 3 directions that we all know about, length, width, and height. Okay, so it's expanding. Okay, that's what it is. That's what the green line represents. Now that sounds like a vector to me, because that's what we've always identified vectors with. Mathematical vectors, by the way. Okay, so here it is. Okay, here you see it. This is the definition of vector. Okay, this is out of Wikipedia. You can find it anywhere else as well. Vector, a geometric object. Okay, and you can see it's an object. It looks like a line with an arrow at the end, right? That has magnitude or length, it says, and direction. Represented by a directed line segment. Not a line, but a line segment. The difference is line is, in the religion of math, it's infinite, has no endpoints, and a segment does. Okay? Graphically, as an arrow connecting an initial point A with a terminal point B. So you can see it starts at A, and it's indicating motion, okay, magnitude, and direction. Direction, well, only because it's got motion. Okay? Vectors can be added to other vectors. Well, we don't add vectors in physics, but they do apparently, whatever vectors are in math, they do seem to add them. And the only reason they can add them is that they represent magnitude. But what are they? What is this vector showing? The blue one there. It's showing what we're seeing with time on the left-hand side. It's showing that there is motion. Okay, if you put the A where the one corner of the small box is, and you put B where the corner of the big box is, you can see what's happened. There's been motion from A to B. So time is not really a dimension, because dimensions are only x, y, z, meaning length, width, and height, unless there's another name for them. I don't know. Maybe math has some name for them that we are not aware of. But time cannot be a dimension. It's more like a vector, because they're talking about motion, in this case, going from A to B. And in the case of the tesseract or hypercube, it's happening radially. It's happening all around. Okay, this thing is expanding in every direction. Okay, so I hope we got that. But there's there's a bigger problem also with the tesseract, and it's you can see not only is it expanding. Okay, that's the first thing you have to keep in mind. But it turns out that you will see out there that they rotate they'll show you the tesseract rotating. Okay, so now we're rotating time. I hope that sinks in. They're rotating time. Here's an illustration of what I'm talking about. Here's the hypercube or tesseract. Okay, you see it. What is a tesseract? Tesseract is a little cube that expands and becomes a big cube. That's what the yellow boxes there show. It goes from a small cube to a big cube. Okay, so they illustrate this whole movie in a single image, a static image, and they say, okay, look, it's expanded. And so we started out with a little cube. The arrows, the vectors, pointing outwards, showing that the corners are growing in size. Everything's expanding, like if it were a balloon. And it makes this bigger cube, and they call that whole shebang a tesseract, and they say it's an object. Well, we understand the object. It's just two nested cubes. That object we understand. None of that is four-dimensional. Okay, that's just a nested cube. One cube inside another. That's all it is. But what it represents is what you have to understand. What you're staring at is not a still image. What you're staring at is a movie of a box expanding. Okay, that's what a tesseract is. But they do something worse, and you see that on the bottom left-hand side there, the white ones. And the way they create every image here, because they're going to rotate this cube. First, the cube has to expand. You take a snapshot of that final cube. That's one frame of the movie. Now this thing rotates a little bit, okay? Now, but it's already small again. Now that one expands, and now you take a snapshot of that one, and so you have this movie of movies. Okay, you have a movie of a box that's expanding, and then you have a movie of that motion being rotated. So you're rotating time whenever you rotate a tesseract. Scary stuff, okay? I can only comprehend it after 10 beers. Otherwise, you can't figure this out, okay? So, yeah, very scary stuff. So, yeah, so the question is, what is time? Is time a dimension or is it a vector? And what is the difference? Well, the vector is, again, motion from A to B. And that's what time is, because they're looking at magnitude and motion. And that's a vector. So why do they say it's dimension? Are they saying that dimensions and vectors are the same? Dimension is defined as a coordinate, as a number of coordinates, number of numbers, because a coordinate is a number. That's not what a vector is defined as in mathematics. It's defined as magnitude and direction. The problem with that, you cannot blend, you cannot merge, you cannot reconcile. Okay? Magnitude with direction. One has nothing to do with the other. Magnitude belongs to math. Direction is a concept that belongs exclusively to physics. Mathematics has no use for direction. You don't add directions. East plus east, what does that give you? Bigger east? North plus north? Left plus left? Forward plus forward gives you more forward? You don't add directions, okay? So that's the big issue. The issue is that you cannot blend what they're saying. Vector being magnitude and direction, okay? It's either magnitude or it's direction. So number is to count, okay? We got that? Numeral, what was a numeral? Numeral is the symbol you use to represent the verb to count. How many counts you made, okay? Number line, it's essentially, a bunch of numbers. That's all it is. Do they fall on a line? No, you can't put numbers on a line. It makes no sense. Okay, to say, oh, they're on the same line. So, like you see there, 1, 2, 3, 4, 5. It makes no sense. That's just put in there so that it's nice to the eyes. Like saying, okay, the 2 follows 1. Okay, I understand that. It's bigger than the 1. And the 3 is bigger than the 2. And so we're going to put some kind of direction to make it easy on the eyes. But, when you're counting 2, 3, 4, 5, there is no direction. Number 2 doesn't fall eastwards of the number 5 or northwards or westwards of the number 5 or left and right, whatever coordinate system you use out there, whatever lines you use out there to represent location. There is no location for numbers. So you cannot say the number 2 is on the right hand side of the 5. It makes no sense. So number line, it has no direction, only has numbers, okay? And that's the scientific definition. Bunch of numbers, okay? That's the scientific definition of number line. Take it from me, okay? Bunch of numbers. Has no direction, no orthogonality. Those two qualitative properties, parameters, whatever, they belong exclusively to physics. They don't belong to math at all. Math has no use for direction or for orthogonality. No use whatsoever. And by orthogonality, I don't mean 90-degree angle. No, that's not what we mean. Orthogonality means that you put the plumb bob so that it points to the center of the earth and you see the horizon. We call that orthogonal. Now, if you want to put 90 degrees, you want to put 100 degrees there, you have your own system of angles, your own angular degrees. Hey, go ahead, invent your own system. No problem. It can be 100, 180, 500. Use whatever numbers you want. But perpendicularity, orthogonality, just means that one is like this, the other one is horizontal. One is vertical versus the other. Okay, that's all it means in physics. Okay, one is perpendicular to the other, means it's one is vertical, the other one is horizontal. Okay, so number line only has magnitude. Mathematicians confuse the number line with dimensions, coordinates, and vectors. And there you can see what's happening. You have these magnitudes, 1 through 5, whatever. Okay, that's got nothing to do with physics. Physics, we have length, width, and height. That's the dimensions. Okay, it's got nothing to do with the coordinate system, numbers, tick marks, location of a point within that group. Within those coordinates, as they call them. They're all number lines. One number line is pointed upwards, the other number line is going sideways. They call this a coordinate system. No, that's not coordinate. Those are number lines, not coordinates. Coordinates are, longitude, altitude, and elevation. Those are coordinates. Not elevation. Altitude, longitude, and radius. Radius? No? Or the other one. Altitude, longitude, and latitude. Those are the three. Okay, but nothing to do with number lines. You don't need to have values for any of those qualitative coordinates. Okay, so here we have a little bit of a summary for all this. We have what's a vector in math? Okay, this is the mathematical vector, not the one of physics. Magnitude and direction. That seems to be a number line because number line is magnitude and direction. That's all it has, magnitude, but not direction. Direction belongs to physics. You can't depict number line with a line. Makes no sense to depict a number line with a line. Again, you cannot say that the number 3 is to the left or the right of the number 6. You can put them any way you want because it has nothing to do with direction. Okay? We artificially put them in a certain direction so that people say, oh, it's in an organized manner. 4 follows 3, which follows 2, which follows 1. We don't care about that in physics. Physics makes no sense to say that. Okay, line belongs exclusively to physics because it's an object, and math has no use for objects. Okay? Then you have direction. Again, it belongs exclusively to physics. Math has no use for direction. We do not add or subtract directions. East from east, subtract west from east. Yes, I don't know. Number line belongs exclusively to math, not to physics, okay? And whereas the dimensions, coordinates, and vectors, they belong exclusively to physics. What are dimensions? Length, width, and height. And coordinates, see if I can still remember that. Altitude, longitude, and is it latitude? And what are three vectors? Again, there's only three of them. There's only three perpendicular directions in which you can move, and that's what vectors are: motion. And from a given point, a reference point, you can only move in three perpendicular directions. Okay, and one is depth, the other one is breadth, and the other one is elevation. So those are the three vectors. Have to do solely with physics. Okay, they have nothing at all to do with math. Number lines, numbers, ticks, and direction or magnitude, as they say, right? Okay, so they invented mathematical physics. What is mathematical physics? Mathematical physics is an attempt to merge numbers with objects. And the first religion was geometry. Okay? Geometry was the first one that tried to put numbers or explain or describe really in terms of numbers objects, especially angles and lines and points and all that stuff. They started putting numbers. So the points became numbers. They put many points. They call that a number line, because what is a line made of? Points, right? You figure that out, right? And then planes are made of lines, also of points. And solids are made of many planes, which are made of lines, which are made of points. And what did they do? They started putting numbers to all that because they wanted to see quantitative relationship, especially between angles. And that whole thing, trig and geometry, all that stuff, that was our first religion because we started putting numbers to objects. And they're incompatible. And numbers, you can do all the equations you want. That belongs to math. The object and relations, you don't need to have quantitative relations. You can have qualitative relationships, okay, which is all that Mother Nature understands. And those belong exclusively to physics. So yeah, math and physics can never merge. Math is not the language of physics, never will be, okay? And that's how we're in the big mess that we are today, the fact that they created this religion known as mathematical physics. It's an attempt to merge physics objects, right, with numbers. And that's how we ended up with black holes and Big Bang and all this nonsense we have today. Okay, so here's a corollary for all that. It says dimension is defined as the number of numbers. They call it the number of coordinates. What is a coordinate? A number. So it's the number of numbers. That's the scientific definition from mathematical physics for the word dimension. Okay. So again, that's got to do solely with math. Okay. Vector is defined as magnitude and direction. Okay, even though the math has no purpose for direction. Mathematicians allege that time has magnitude and direction. Okay, so if time has magnitude and direction, which is what vector has, magnitude and direction, then pursuant to their own definition, time is a vector and not a dimension. Okay, so when they say that there's something called four-dimensional space-time, ask them, which dimensions are those? Length, width, and height? And then you have the dimension of time. No, time, if anything, is a vector. You can say it's 3 and 1 at best. But it turns out length, width, and height are not the dimensions they're talking about. In fact, they confuse them all the time. They put length together with altitude, which is a coordinate. And length is or width, any of those. Those are dimensions. So they mix dimensions with coordinates, with vector. They call them depth or breadth. They don't care. They use all these words interchangeably because they're not talking about physics. They're talking about number lines. And they just make the mistake of saying, oh, this is a vector, so I'm going to call this one depth. And that one's a coordinate, and so I'll call it altitude. And the other one is dimension, and I'll call it width. And then they mix them up, and they don't care. And then they can put time in there because for them it's all just number lines. None of these have anything to do with dimensions, coordinates, or vectors.